So welcome back to grade 7 math. We are now on chapter 9.3, which is on multiplying a whole number by a fraction. It's a really simple lesson for grade 7. It gets a little bit more complicated in grade 8, but in grade 7 it's pretty simple. You can look at page 312 in the Nelson textbook if you want to follow along. Here's the method. First of all, this is a grade 8 rule, but we convert all mixed fractions to improper fractions. In grade 7, there's no necessary need to do that, but just change all of your mixed fractions into improper fractions. The reason why is that when you have a mixed and improper fraction, it ends up making two parts to it. And when you have two parts to a fraction, it makes it a little bit more difficult to multiply since we're finding areas with two parts. When you have one part and we change it to improper fractions, then it's a lot easier to perform the operations. Multiply the numerators together and then multiply the denominators together, reduce and convert back to a mixed fraction. A lot of these rules are grade 8 kind of rules, so let's take a look at an example and see how this makes sense first, and then we can reapply those rules if we need to at this level. Here's an example. After a birthday party, Jenna notices she still has 3 containers of lemonade that are still 1/4 filled. If she adds them all together, how much lemonade or how many containers of lemonade does she have? Well, let's just draw this container of lemonade, and it's approximately 1/4 filled with this red looking Kool-Aid lemonade. So she has a total of 3 containers that are 1/4 filled. This is not a great fraction. But if I add them all together, how much lemonade does she have? So let's just rewrite this as 1/4 plus 1/4 plus 1/4. And as we learned in earlier grades, this is a repeated addition, or you can represent this as a multiplication, 3 times 1/4. Well, if we add these 3 together, we know that quite simply 1/4 plus another quarter plus another quarter equals 3/4. Well, how did I get that from the multiplication? What this really means is I have 3 whole things times one piece that is cut into 4. Or one whole that's cut into 4. So if I have 3 of those, that means I have 3 pieces of those 4th pieces. So I'm multiplying only the numerators together. So let me just get another color here. My 3 times 1 gives 3, and my 4 just stays the 4 at the bottom. So now let's try a couple of other examples with this. What is 3 times 4/5? Well, let's rewrite this as 3 times 4/5. And so the rule is we multiply our numerators together and then we multiply our denominators together. And we learned earlier on that 3 is the same thing as 3 whole. 3 whole jars or 3 whole times. So 3 wholes is the same as 3. 3 wholes times 4/5. I multiply my numerators together, so 3 times 4 is 12. And I multiply my denominators together, 1 times 5 is 5. So 12/5 is my answer. How can I see if this is correct? Well, I can actually do 3 times 4/5 is the same thing as 4/5 plus 4/5 plus 4/5, just like in repeated addition. Well, that means my fifths always stay the same. They're the same size pieces. However, my numbers of those pieces increase. So 4 plus 4 plus 4 is 12. I can now reconvert this into a mixed fraction by seeing how many times does 5 go into 12, and it goes into it 2 times. My remainder, I have, well, 5 goes into 12 2 times, which is 10, and then if I take 10 away from 12, I'll be left over with 2. So my answer of 3 times 4/5 is 2 and 2/5. What is 6 times 6/7? Well, if I have, what is 7 times 6/7? So what I'll do again is I multiply my numerators. So 7 times 6 is 42. And my denominators, well, this is 7 whole ones, so 1 times 7 is 7. Then I can convert this. How many times does 7 go into 42? And it goes into it 6 times. Wow, we just noticed something really weird here. Well, that 6 appears here as well. So let's just take a look at this in a different way. 7 times 6/7. What this means is I have something that's cut into 7 pieces. And I have 6 of those pieces that is cut into the 7 pieces. If I multiply it times 7, that means each one of those pieces will end up turning into a whole amount eventually. Well, what that means is I can cancel the 7 and the 7, meaning that I have just the 6 pieces that now become 6 wholes because I have all of my pieces have turned into wholes. So that's another way of solving this. If this is too complicated, don't worry. This is at grade 8 level in order to do these canceling out methods. So if you're okay with just this part, then you should be okay for the test. Multiply 3 times 5/12. And the last example, using the fraction strips, multiply 4 times 2/3. So pause the video and try these couple of examples, and then we'll go through the answers together. Well, 3 times 5/12. Again, 3 is the same as 3 whole numbers. So 3 times 5 is 15. 1 times 12 is 12. I find out how many times does 12 go into 15. It goes into it 1 time. I'm left with a remainder of 3. And now I can reduce my top and bottom. Both of these have a common factor of 3. My 1 still stays there, but 3 divided by 3 is 1. 12 divided by 3 is 4. So my answer is my answer to the question 3 times 5/12 is 1 1/4. Using a model, show that 4 times 2/3 equals 8/3. Well, what I can do here is I have 2/3, so I'll color them in pretty quickly. And I'll color this one in. And this one in. Whoa, that's a not so good coloring. And then the last one down here, terrible coloring. But given this, I can show that my total amount is, if I count 1, 2, 3, 4, 5, 6, 7, 8, that 4 times 2/3 equals 8/3. So this is how I can model that. Then if I wanted to represent that, I can move some of these over. So let's just move some of them. So let's just take this one and move that one up over there. And I'll take this one and I'll move it up over to this one. So these two now move in here. So this one and this one. So those two that were down here, I just moved them up. And now I see I have 1 full bar, 2 full bars, and 2/3 of another bar. So that's how I know that 8/3 is the same as 2 and 2/3. Try out these examples on multiplication. Make sure you practice also conversion of improper to mixed and back from mixed to improper fractions as well. So we'll take a look at these questions in class and review this video if you need to, but hopefully you understood this lesson.